Hi, it's Mrs. Nandor, and in this video we're going to talk about the law of conservation of mass. So first let's talk about what it means for something to be conserved and not conserved, because it's a little bit opposite of what we would normally think of. So if something is conserved, it means that it is not changed. So it stays the same. So if we're talking about conserving mass, it means that our mass is not changing. The opposite is true for not conserved. So if we say something is not conserved, if mass is not conserved, it means it changes. So if we're talking about conserving mass, we're not changing the mass. If we're talking about not conserving the mass, we are changing the mass. So it's a little bit backwards of what we would typically think. So conserved means not changed, it's the same. Not conserved means it's changed, it's different. So this is the same, this is different. So now let's talk about our law of conservation of mass. So there are two ways that we're going to word this. The first way that we're going to word this is we're going to look at a specific system, or the law of conservation of system mass. So we did this in our lab. We had a set system, and we were measuring whether or not the mass changed. What we saw was that the mass changed if and only if something, matter, particles, entered or left our system. So mass changes only when particles enter or leave the system. So if when you make the change, it means something is leaving the system, you can't contain it, your mass has changed. And their mass changes only because something left the system. The opposite is true for things being added to the system. If you didn't originally measure it, if it wasn't in your original defined system, but it gets added through some sort of physical or chemical process, and it's now there, it enters your system, your mass is not conserved. So your mass is only going to change if something enters or leaves your system. If something doesn't enter or leave, your mass should stay the same, no matter what you're doing. As long as nothing's entering or leaving, your mass is always going to be conserved. So let's broaden this a little bit. So in lab, we had a specific set defined system. What if we consider the entire universe our system? Can anything enter or leave our universe? Now we could get super theoretical about this, but let's just say no. Nothing can ever enter or leave our universe once it's here. It's always going to be here. That being said, can mass ever change? If we think about this on the scale of the universe, mass is never going to change. And this ties into probably the law of conservation of mass that we've heard before, which is matter cannot be created or destroyed. What this means is when we make measurements in lab and we see that our mass changes, there is always some sort of explanation. Did something leave our system? Did something enter our system that we haven't accounted for? Did we do something wrong? Did we lose matter somehow? Did it end up on our lab bench instead of on our balance or in our test tubes or whatever we're using? But matter cannot be created or destroyed. It just gets moved in and out of our measurable systems. So this is our law of conservation of mass.